Hey there, folks. Today, we're diving into the fascinating world of vehicle armor. Vehicle armor is a crucial component in protecting our vehicles from potential threats. It's made up of a variety of materials, including metals like steel, aluminum, and iron, as well as non-metals like titanium, uranium, and even plastic. Now, let's talk about the different types of armor. We have composite armor, which is a combination of materials designed to provide maximum protection. We also have ships, aircraft, and armored fighting vehicles, which are all equipped with their own unique armor systems. When it comes to layout, there are a few key concepts to keep in mind. Spall liners, applique, and improvised armor are all important factors to consider. Additionally, spaced, sloped, reactive, slat, and electric armor all play a role in the overall protection of our vehicles. That's a wrap for today's armor discussion. Thanks for tuning in. If you found this information helpful, don't forget to like, share, and subscribe for more fascinating facts. Stay safe, and see you next video. Military vehicles are commonly armored or armored. See spelling differences to withstand the impact of shrapnel, bullets, shells, rockets, and missiles, protecting the personnel inside from enemy fire. Such vehicles include armored fighting vehicles like tanks, aircraft, and ships. Civilian vehicles may also be armored. These vehicles include cars used by officials, for example, presidential limousines, reporters, and others in conflict zones or where violent crime is common. Civilian armored cars are also routinely used by security firms to carry money or valuables or reduce the risk of highway robbery or the hijacking of the cargo. Armor may also be used in vehicles to protect from threats other than a deliberate attack. Some spacecraft are equipped with specialized armor to protect them against impacts from micrometeoroids or fragments of space debris. Modern aircraft powered by jet engines usually have them fitted with a sort of armor in the form of an aramid composite kevlar bandage around the fan casing or debris containment walls built into the casing of their gas turbine engines to prevent injuries or airframe damage should the fan, compressor, or turbine blades break free. 1. The design and purpose of the vehicle determines the amount of armor plating carried, as the plating is often very heavy and excessive amounts of armor restrict mobility. In order to decrease this problem, some new materials, nanomaterials, and material compositions are being researched, which include bucky paper to and aluminum foam armor plates. 3. Metals, steel, rolled homogeneous armor is strong, hard and tough, does not shatter when struck with a fast, hard blow. Steel with these characteristics is produced by processing cast steel billets of appropriate size and then rolling them into plates of required thickness. 4. Rolling and forging, hammering the steel when it is red hot irons out the grain structure in the steel, removing imperfections which would reduce the strength of the steel. 5. Rolling also elongates the grain structure in the steel to form long lines, which enables the stress the steel is placed under when loaded to flow throughout the metal and not be concentrated in one area. 4. Cast homogeneous armor or cast steel armor is produced by directly casting steel into the desired shape. 6. It tends to be softer as heat treatment is difficult or impossible. Nevertheless, the flexibility in shape has made it popular as the structural hull in modern tanks. 7. Aluminium. The British Fox EVRW was built largely of aluminium. Aluminium is used when lightweight is a necessity. It is most commonly used on APCs and armored cars. While certainly not the strongest metal, it is cheap, lightweight, and tough enough that it can serve as easy armor. Iron. Wrought iron was used on ironclad warships. Early European iron armor consisted of 10 to 12.5 centimeters of wrought iron backed by up to 1 meter of solid wood. It has since been replaced by steel due to steel being significantly stronger. Titanium. Titanium has almost twice the density of aluminium, but can have a yield strength similar to high-strength steels, giving it a high specific strength. It also has a high specific resilience and specific toughness. So, despite being more expensive, it finds an application in areas where weight is a concern, such as personal armor and military aviation. Some notable examples of its use include the US FA-10 Thunderbolt II and the Soviet, Russian-built Sukhoi Su-25 ground attack aircraft, utilizing a bathtub-shaped titanium enclosure for the pilot, as well as the Soviet, Russian Mi-20 for attack helicopter. Uranium, because of its high density, depleted uranium can also be used in tank armor. sandwich it between sheets of steel armor plate. For instance, some late production M1A1HA and M1A2 Abrams tanks built after 1998 have due reinforcement as part of the armor plating in the front of the hull and the front of the turret, and there is a program to upgrade the rest. See Chobham armor. Plastic. Main article. Plastic armor. Plastic metal was a type of vehicle armor originally developed for merchant ships by the British Admiralty in 1940. The original composition was described as 50% clean granite of half-inch size, 43% of limestone mineral, and 7% of bitumen. It was typically applied in a layer 2 inches thick and backed by half an inch of steel. Plastic armor was highly effective at stopping armor-piercing bullets because the hard granite particles would deflect the bullet, which would then lodge between plastic armor and the steel backing plate. Plastic armor could be applied by pouring it into a cavity formed by the steel backing plate and a temporary wooden form. Some main battle tank armor utilizes polymers. For example, polyurethane is used in the BDD applique armor applied to modernize T-62 and T-55. Glass. Main article. Bulletproof glass. Ballistic test of a bullet-resistant glass panel. Bulletproof glass is a colloquial term for glass that is particularly resistant to being penetrated when struck by bullets. The industry generally refers to it as bullet-resistant glass or transparent armor. Bullet-resistant glass is usually constructed using a strong but transparent material such as polycarbonate thermoplastic or by using layers of laminated glass. The desired result is a material with the appearance and light-transmitting behavior of standard glass, which offers varying degrees of protection from small arms fire. The polycarbonate layer, usually consisting of products such as Armour Max, Macroclear, Ceralon, Lexan, or Tuffic, is often sandwiched between layers of regular glass. The use of plastic in the laminate provides impact resistance, such as physical assault with a hammer, an axe, etc. The plastic provides little in the way of bullet resistance. The glass, which is much harder than plastic, flattens the bullet and thereby prevents penetration. This type of bullet-resistant glass is usually 70 to 75 mm to 0.8 to 3.0 in thick. Bullet-resistant glass constructed of laminated glass layers is built from glass sheets bonded together with polyvinyl butyryl, polyurethane, or ethylene vinyl acetate. This type of bullet-resistant glass has been in regular use on combat vehicles since World War II. It is typically about 100 to 120 mm, 3.9 to 4.7 in thick and is usually extremely heavy. Newer materials are being developed. One such, aluminium oxynitride, is much lighter, at a $10 to 15 per square inch, is much more costly. Ceramic. Main article. Ceramic plate. Ceramic's precise mechanism for defeating heat was uncovered in the 1980s. High-speed photography showed that the ceramic material shatters as the heat round penetrates the highly energetic fragments, destroying the geometry of the metal jet generated by the hollow charge, greatly diminishing the penetration. Ceramic layers can also be used as part of composite armor solutions. The high hardness of some ceramic material serves as a disruptor that shatters and spreads the kinetic energy of projectiles. Composite. Blazon Sandcat light 5-ton military vehicle featuring integrated composite armored body. Main article. Composite armor. Composite armor is armor consisting of layers of 2 or more materials with significantly different physical properties. Steel and ceramics are the most common types of material in composite armor. Composite armor was initially developed in the 1940s, although it did not enter service until much later, and the early examples are often ignored in the face of newer armor such as Chobham armor. Composite armor's effectiveness depends on its composition and may be effective against kinetic energy penetrators as well as shaped charge munitions. Heavy metals are sometimes included specifically for protection from kinetic energy penetrators. Composite armor used on modern Western and Israeli main battle tanks largely consists of non-explosive reactive armor or NERA elements, a type of reactive armor. These elements are often a laminate consisting of 2 hard plates, usually high-hardness steel with some low-density interlayer material between them. Upon impact, the interlayer swells and moves the plates, disrupting heat jets and possibly degrading kinetic energy projectiles. Behind these elements will be some backing element designed to stop the degraded jet or projectile element, which may be of high-hardness steel, or some composite of steel and ceramic, or possibly uranium. Soviet main battle tanks from the T-60 for onward utilized composite armor, which often consisted of some low-density filler between relatively thick steel plates or castings, for example combination K8. For example, the T6 for turret had a layer of ceramic bowls and aluminium sandwiched between layers of cast steel armor, while some models of the T7 to features a glass filler called quartz. The tank glacis was often a sandwich of steel and some low-density filler, either textilite of fiberglass reinforced polymer or ceramic plates. 10. Later T80 and T7 to turrets contained narrow elements, similar to those discussed above. 11-12. Ships. Diagram of common elements of warship armor. The belt armor is denoted by a belt armor is a layer of armor plating outside the hull of warships, typically on battleships, battlecruisers, cruisers and some aircraft carriers. 13. Typically, the belt covers from the deck down some way below the waterline of the ship. If built within the hull, rather than forming the outer hull, it can be fitted at an inclined angle to improve the protection. When struck by a shell or torpedo, the belt armor is designed to prevent penetration by either being too thick for the warhead to penetrate or sloped to a degree that would deflect either projectile. Often, the main belt armor was supplemented with a torpedo bulkhead spaced several meters behind the main belt, designed to maintain the ship's watertight integrity even if the main belt were penetrated. The air space between the belt and the hull also adds buoyancy. Several wartime vessels had belt armor that was thinner or shallower than was desirable to speed production and conserve resources. Deck armor on aircraft carriers is usually at the flight deck level, but on some early carriers was at the hangar deck. See armored flight deck. Aircraft armor plating is not common on aircraft, which generally rely on their speed and maneuverability to avoid attacks from enemy aircraft and ground fire, rather than trying to resist impacts. Additionally, any armor capable of stopping large caliber anti-aircraft fire or missile fragments would result in an unacceptable weight penalty. So, only the vital parts of an aircraft, such as the ejection seat and engines, are usually armored. This is one area where titanium is used extensively as armor plating. For example, in the American Fairchild Republic A-10 Thunderbolt II and the Soviet-built Sukhoi Su-25 ground attack aircraft, as well as the Mi-20 for Hind ground attack helicopter, the pilot sits in a titanium enclosure known as the bathtub for its shape. In addition, the windscreens of larger aircraft are generally made of impact-resistant, laminated materials, even on civilian craft, to prevent damage from bird strikes or other debris. Armored fighting vehicles. Main article, Armored fighting vehicle. The most heavily armored vehicles today are the main battle tanks, which are the spearhead of the ground forces and are designed to withstand anti-tank guided missiles, kinetic energy penetrators, high-explosive anti-tank weapons, NBC threats and in some tanks even steep trajectory shells. The Israeli Merkava tanks were designed in a way that each tank component functions as added backup armor to protect the crew. Outer armor is modular and enables quickly replacing damaged parts. Layout. For efficiency, the heaviest armor on an armored fighting vehicle AFV is placed on its front. Tank tactics require the vehicle to always face the likely direction of enemy fire as much as possible, even in defense or withdrawal operations. Sloping and curving armor can both increase its protection. Given a fixed thickness of armor plate, a projectile striking at an angle must penetrate more armor than one impacting perpendicularly. An angled surface also increases the chance of deflecting a projectile. This can be seen on V-hull designs, which direct the force of an improvised explosive device or landmine away from the crew compartment, increasing crew survivability. 14. Spall liners. Beginning during the Cold War, many AFVs have spall liners inside of the armor, designed to protect crew and equipment inside from fragmentation spalling released from the impact of enemy shells, especially high-explosive squash-head warheads. Spall liners are made of aramids Kevlar, Taurin, UHMWP Dyneema, Spectra Shield, or similar materials. Applic, Vehicle Composite Add-on Armor Kit. Applic Armor, 15, or add-on armor, consists of extra plates mounted onto the hull or turret of an AFV. The plates can be made of any material and are designed to be retrofitted to an AFV to withstand weapons that can penetrate the original armor of the vehicle. 1617. An advantage of applic armor is the possibility to tailor a vehicle's protection level to a specific threat scenario. Improvised. Main article, Improvised vehicle armor. Vehicle armor, sometimes improvised in the midst of an armed conflict by vehicle crews or individual units. In World War II, British, Canadian and Polish tank crews welded spare strips of tank track to the hulls of their Sherman tanks. 18 U.S. tank crews often added sandbags in the hull and turrets on Sherman tanks, often in an elaborate cage made of girders. Some Sherman tanks were up-armored in the field with glacis plates and other armor cut from knocked-out tanks to create improvised jumbos, named after the heavily armored M4A3E2 assault tank. In the Vietnam War, U.S. gun trucks were armored with sandbags and locally fabricated steel armor plate. 19 more recently, U.S. troops in Iraq armored Humvees and various military transport vehicles with scrap materials. This came to be known as hillbilly armor or hijacking armor by the Americans. 18. Moreover, there was the killdozer incident, with the modified bulldozer being armored with steel and concrete composite, which proved to be highly resistant to small arms. Spaced. Main article. Spaced armor. Sturmgeschütz 3 with spaced armor plates. Armor with 2 or more plates spaced a distance apart, called spaced armor, has been in use since the First World War, where it was used on the Schneider CA-1 and Saint-Chamond tanks. Spaced armor can be advantageous in several situations. For example, it can reduce the effectiveness of kinetic energy penetrators because the interaction with each plate can cause the round to tumble, deflect, deform, or disintegrate. This effect can be enhanced when the armor is sloped. Spaced armor can also offer increased protection against heat projectiles. This occurs because the shaped charge warhead can detonate prematurely at the first surface, so that the metal jet that is produced loses its coherence before reaching the main armor and impacting over a broader area. Sometimes the interior surfaces of these hollow cavities are sloped, presenting angles to the anticipated paths of the shaped charge's jet in order to further dissipate its power. Taken to the extreme, relatively thin armor plates, metal mesh, or slatted plates, much lighter than fully protective armor, can be attached to side skirts or turret skirts to provide additional protection against such weapons. This can be seen in Middle and Late World War II German tanks, as well as many modern AFVS. Taken as a whole, spaced armor can provide significantly increased protection while saving weight. The analogous Whipple shield uses the principle of spaced armor to protect spacecraft from the impacts of very fast micrometeoroids. The impact with the first wall melts or breaks up the incoming particle, causing fragments to be spread over a wider area when striking the subsequent walls. Sloped. The Merkava features extreme sloped armor on the turret. Main article. Sloped armor. Sloped armor is armor that is mounted at a non-vertical and non-horizontal angle, typically on tanks and other armored fighting vehicles. For a given normal to the surface of the armor, its plate thickness, increasing armor slope improves the armor's level of protection by increasing the thickness measured on a horizontal plane, while for a given area density of the armor the protection can be either increased or reduced by other sloping effects, depending on the armor materials used and the qualities of the projectile hitting it. The increased protection caused by increasing the slope while keeping the plate thickness constant, is due to a proportional increase of area density and thus mass, and thus offers no weight benefit. Therefore, the other possible effects of sloping, such as deflection, deforming and ricochet of a projectile, have been the reasons to apply sloped armor in armored vehicles design. Another motive is the fact that sloping armor is a more efficient way of covering the necessary equipment since it encloses less volume with less material. The sharpest angles are usually seen on the frontal glacis plate, both as it is the hull side most likely to be hit, and because there is more room to slope in the longitudinal direction of a vehicle. Reactive. M60A1 Patton tank with Israeli Blazer era. Main article. Reactive armor. Explosive reactive armor. Initially developed by German researcher Manfred Held while working in Israel, uses layers of high explosive sandwich it between steel plates. When a shaped charge warhead hits, the explosive detonates and pushes the steel plates into the warhead, disrupting the flow of the charge's liquid metal penetrator, usually copper, at around 500 degrees Celsius. Citation needed. It can be made to flow like water by sufficient pressure. Traditional light era is less effective against kinetic penetrators. Heavy reactive armor, however, offers better protection. The only example currently in widespread service is Russian Contact 5. Explosive reactive armor poses a threat to friendly troops near the vehicle. Non-explosive reactive armor is an advanced spaced armor which uses materials which change their geometry so as to increase protection under the stress of impact. Active protection systems use a sensor to detect an incoming projectile and explosively launch a counter-projectile into its path. Slat. Main article. Slat armor. IDF Caterpillar D9 armored bulldozer with slat armor in addition to armor plates and bulletproof windows. The D9 armor deflected RPG rockets and even 9K11 Malyutka AT-3 Sagar ATG miss. Slat armor is designed to protect against anti-tank rocket and missile attacks where the warhead is a shaped charge. The slats are spaced so that the warhead is either partially deformed before detonating or the fusing mechanism is damaged, thereby preventing detonation entirely. As shaped charges rely on very specific structure to create a jet of hot metal, any disruption to this structure greatly reduces the effectiveness of the warhead. 20 slat armor can be defeated by tandem charge designs such as the RPG-27 and RPG-29. 21. Electric armor. Main article. Electric armor. Electric armor is a recent development in the United Kingdom by the Defence Science and Technology Laboratory. 20 to 23, 20 for 25, 26, 27, 28. A vehicle is fitted with two thin shells, separated by insulating material. The outer shell holds an enormous electric charge, while the inner shell is at ground. If an incoming heat jet penetrates the outer shell and forms a bridge between the shells, the electrical energy discharges through the jet, disrupting it. Trials have so far been extremely promising, and it is hoped that improved systems could protect against KE penetrators. The developers of the future rapid effect system for a series of armored vehicles are considering this technology. See also, active protection system. Armored fighting vehicle, armored forces, main battle tank. Non-military armored vehicles, personal armor, plastic armor.